This is a fun question. It's asking us to approximate the mass of the galaxy. So here's a picture of our Milky Way galaxy, and here's a side view. So we have what's called the galactic bulge, where at the center it's apparently a giant black hole that is holding everything in, holding everything together. So that is what's causing the force that allows our sun and solar system to orbit around that black hole. So our task, calculate the mass of the galaxy. So once, just like in the previous one, we have the centripetal force is equal to our force of gravity. So just a bunch of algebra to start with. So we have the mass of our sun, or our solar system, multiplied by the velocity squared of however fast it's traveling around that galactic bulge, and divided by the radius, and this is equal to g, and the mass of our sun has the mass of the galaxy itself divided by r squared. If we rearrange for velocity, we get v squared is equal to gm of the galaxy. The masses of our solar system is cancelled out, divided by r. But we don't want v, we want to solve for time. Well, actually not time, we're actually solving for the mass of the galaxy, but it's easier if we replace that with the other equation for velocity. V is equal to 2 pi r over t. And this becomes 4 pi squared r squared over t squared is equal to gm over r. So if we rearrange our equation for the mass of the galaxy, we end up with 4 pi squared r cubed over the gravitational constant divided by t squared. Now in the question they give us a few things. So it says that the sun orbits around the center of our galaxy once every 2.5 times 10 to the 8 years. So that's our period. T is equal to 2.5 times 10 to the 8 years. So you'll have to convert that into seconds before you plug into the equation. For r, the distance from the galactic bulge to the sun is 27,000 light years. So r is equal to 27,000 light years from the center. So we have to find out how many meters. We have to convert that into meters, and the value for that is, we're going to multiply that by 9.46 times 10 to the 15 meters for every light year. So it's a huge distance. We're going to plug in all those values, and we get a value of, so give that a go and pause it to make sure you can get the following. We get a value of approximately 1.6 times 10 to the 41 kilograms. So afterwards I did look this up on Google, and it says in reality the mass of the galaxy is 6 times 10 to the 42 kilograms. So I think we're pretty darn close though, only one order of magnitude off. But also this is assuming that there's that center thing that's pulling the sun in towards it. But there's a lot of other mass out in the outer part of the galaxy, so that probably takes into account that extra factor of 10. Next part is saying, assuming that a typical star contains 10 times the mass of our sun. So our sun is actually smaller than the majority on average. So our sun is around 2 times 10 to the 30 kilograms. However, most stars on average, if you take, it's about 10 times greater. So if we take the number of stars, if we actually want to calculate how many there are, so number of stars, if we just take our mass of the galaxy and divide that by 10 times the mass of our sun, we get a value for the number of stars. So based on our estimate, we get around 10 billion. Again, because we're off by a factor of 10, the actual value that scientists have come to, they believe there's approximately 100 billion stars in our Milky Way galaxy.